Good morning, everybody. I am Sau Avtade Madam. Today we are going to discuss the homogeneous equation of degree 2, which is the next part of the video. Let us first study degree of a term. First, see what is the definition of degree of a term. The sum of indices of all variables in a term is called the degree of the term. Consider the example x square plus 3xy minus 2y square plus 5x plus 2. In this equation, consider the term one by one. Let us consider the first term x square. Here the degree of the term x square is 2 because the power of x is 2. Next, consider the term plus 3xy. Here the degree of the term 3xy is 2 because the power of x is 1 and power of y is 1. 1 plus 1 gives 2. So the degree of the term 3xy is 2. Next, consider the term minus 2y square. Here the degree of the term is 2 because the power of the term y is 2. Next, consider the degree of the 5x. That is, degree of the 5x is 1 because the power of the term means here the variable is x. The power of the term 5x is 1. Next, the degree of the term 2 is 0 because it has no variable and the degree of the constant term is always 0. Next, consider the subunit homogeneous equation. Let us see the definition of homogeneous equation. An equation in which the degree of every term is same. Homogeneous means same. Therefore, we called this type of equation as homogeneous equation. Consider the example for this. X square plus 3xy equal to 0. First, consider the term x square. Here already I have explained in previous that the degree of the term x square is 2 and the degree of the plus 3xy. Here also the degree of the term 3xy is 2, means the degree of the first term is 2 and the degree of the second term is also 2, means both are same. Therefore, the degree of this x square plus 3xy equal to 0 is 2. Let us consider the another equation 7xy minus 2y square equal to 0. First term is 7xy. Here there are two variables x and y. The power of x is 1, the power of y is 1. 1 plus 1 gives 2. Therefore, the degree of the term 7xy is 2. Next, consider the term minus 2y square. Here the power of the variable, that is y, is 2. Therefore, it is also 2. Once again, observe the equation. The degree of the first term is also 2. The degree of the second term is also 2. Therefore, it is the best example for homogeneous equation. Okay. Next, another example 5x square plus 3xy minus 2y square equal to 0. Already you come to know that. See here, the degree of the first term is 2, degree of the second term is 2 and the degree of the third term is 2. Therefore, it is also called as a homogeneous equation. Next, the general equation of homogeneous degree can be given by or of the form ax square plus 2hxy plus by square equal to 0. See here the first term ax square, here degree of the term is 2. Here consider a as a constant term, here the variable is only x, therefore the degree of the term is 2. Next, consider the term 2hxy. Here 2h is a constant and the degree of the term is 2 because the power of x is 1 and power of y is 1. Next, consider the term plus by square. Here b is a constant term, variable is y square, therefore degree of the term is 2. Now observe the three terms. We get here the same degree, that is 2, 2, 2. Therefore, it is called homogeneous equation of degree 2 in x and y where a, b and 2h are constant terms. Okay, I think you clear it. Next, we are going to study the theorem, that is the combined equation of pair of lines passing through the origin is a homogeneous equation of degree 2 in x and y. Consider, observe the diagram here. This is a xy plane. There are two lines passing through the origin. One is a1x plus b1y equal to 0 and another one is a2x plus b2y equal to 0. Proof for this: let a1x plus b1y equal to 0. Why the term here c is 0? Because the line is passing through the origin, therefore the constant term is 0. Similarly, for the second equation also, a2x plus b2y equal to 0. This line is also passing through the origin. Therefore, the combined equation, in previous theorem we know that u equal to 0 and v equal to 0, then combined equation can be represented by the letter uv equal to 0 or by the equation uv equal to 0. So that we can write here a1x plus b1y, complete the bracket, and into another bracket a2x plus b2y equal to 0. By multiplication we get a1 a2x square plus a1 b2 xy plus a2 b1 xy plus b1 b2 y square equal to 0. Now consider the term like this: a1 a2, complete the bracket, x square plus into the bracket a1 b2 plus a2 b1, complete the bracket, xy, because in this term xy term is common. Next, plus consider b1 b2 into the bracket and y square equal to 0. In this, if we put a1 a2 equal to small a, a1 b2 plus a2 b1 equal to 2h, b1 b2 equal to b, we get the equation ax square plus 2hxy plus by square equal to 0, which is a homogeneous equation of degree 2 in x and y, because already you come to the know what is the degree. Verify the combined equation of the lines 2x plus 3y equal to 0 and x minus 2y equal to 0 is a homogeneous equation of degree 2. Because here I am going to give one example. Here, next, the combined equation of the lines u equal to 0 and v equal to 0 can be given by uv equal to 0. Therefore, the combined equation of the lines here are 2x plus 3y equal to 0 and x minus 2y equal to 0. These are the separate equations. Now multiply these two equations. 2x plus 3y, complete the bracket, into another bracket x minus 2y equal to 0. After multiplication we get 2x square minus xy minus 6y square equal to 0, which is a homogeneous equation of degree 2. See here, observe the every term you get the degree is 2. Next, remark for this theorem: the combined equation of pair of lines passing through the origin is a homogeneous equation of degree 2, but every homogeneous equation of degree 2 need not present a pair of lines. Equation x square plus y square equal to 0 is a homogeneous equation of degree 2, but it does not represent a pair of lines. How to test whether the given homogeneous equation of degree 2 represents a pair of lines or not? Let's have a theorem. This theorem will be discussed in next period or in the next video.